Hi guys, welcome to the Unit 4 review. On these first four problems, where you really just try to figure out what's going to make the whole thing undefined. And so when that's the question, you don't have anything to do with the numerator. You're just trying to use the denominator, set it equal to zero. I want to know what makes the bottom zero because you can't divide by zero. Okay, so here I'm going to say x plus 4 equals zero, x minus 3 equals zero. I'm going to move each one. So this is going to be x equals negative 4 and x equals positive 3. Okay, so for this problem, negative 4 and 3 are what make this thing undefined. And so this is my answer. Now, okay. Again, I'm not trying to do anything with the top. I don't care if it's a GCF factor or anything. That's a different conversation. If I want to know what makes the whole thing undefined, and just at the bottom equals zero. Now, sometimes you do have to factor the bottom to move forward. And here, this is the difference of two squares. So this is going to be y plus 5, y minus 5. Okay. And so you may already know what this is going to do, but I got y plus 5 equals zero, y minus 5 equals zero. And so this is going to be y equals negative 5, y equals positive 5. And so y equals plus or minus 5. Um, Positive or negative 5 will give you a 0 in the bottom, which makes the whole thing uh, undefined. Okay. Number 3, let's factor this. Okay, you have x minus minus, and it's minus minus because the second side is positive, which means both sides are the same, and both sides are the same as the first. Okay. So what times what is 30 and adds to 11? Well, that's going to be 5 and 6. Okay, so once again, x minus 5 equals 0, x minus 6 equals 0, x equals 5, x equals 6. Right, so x equals positive 5 and 6 will make this whole thing undefined. Okay, so number 4, you have x squared plus 36 equals 0. So x plus 36 equals 0. Now, you maybe already see what's going to happen here, but let's talk through it nonetheless. Um, you have an x squared. The smallest thing I can plug in there is 0. And so if I let 0 be x, then I get 36 equals 0. All right, so let me move the 36 over and see if I can come a little closer to figure out what this is going to be. You get x squared equals negative 36. Well, if you know anything about squares, if you square a number, negative included, you're not going to get a negative out. There's no way you can square a number and get the negative to come out of it. It's kind of like absolute value. Absolute value always produces a negative, a positive number. Right. So this is a situation if you have x squared plus a number, right, that kind of removes the chances of it becoming 0. So since this cannot be 0, this cannot be 0. So it doesn't matter what I plug in, it always works. And so my answer here is going to be all real numbers. It's a beautiful thing when that happens. All right, shifting gears. Starting with number 5, we are actually trying to simplify these things. So now I have to pay attention to the numerator, where I hadn't paid attention to the numerator up to this point. Okay, so on number 5, I'm going to look at the numbers and the x's. Okay, and 6 over 24 is going to be 1 over 4. And then x cubed over x to the 8th. Remember, when you multiply like bases, you add your exponents. And when you when you divide like bases, you subtract your exponents. This is going to be x to the 5th on the bottom. Okay, so 1 over 4x to the 5th is going to be my answer. On number 6, I need to factor the bottom. Okay, so it's going to be negative 32 over, my factor out a GCF of 4, x minus 5. Okay, there's that. And so I can get rid of 4 goes in 4 one time and 32 8 times. Don't forget your negative, but this is going to be negative 8 over x minus 5. Okay, moving on. Okay, on 7, we have 21 and 24. All right, they don't go into each other, but there is something that goes into both of them. And that would be 3. So let me factor out a 3, or GCF. And that's going to leave me with 7x minus 8. Well, 7x minus 8 doesn't show up. I do have similar terms in the bottom, but I don't have the exact layout of 7x minus 8. But can I get there? Well, if I factor out a negative x, right? So I have a positive 8 and a negative 7. That is your indication if the signs are opposite of what I need, all I need to do is take out a negative and fix that. And so when I take out a negative x, I get 7x minus 8 to show up, which means this is going to fall out, and I'm left with 3 over x. And remember, if this is a simple fraction, then I can move that negative either at the top, out front, or leave it on the bottom. So it's really your preference. I'm just going to put it out front. x plus 3, x minus 7. There's no GCF I can take out. There's nothing I can factor. And they definitely don't cancel out with each other. So this is an example of it's already simplified. So it cannot be simplified. In fact, if you remember your instructions right before number 5, it says simplify if possible. And this one, it's not possible to simplify. So cannot be simplified. All right, number 9. Nothing I can do with x minus 12, so I'll just bring it over here. X squared minus 144 is going to be x plus 12, x minus 12. It's really important that you recognize your difference of two squares, right? So I can get rid of my x minus 12s, and I'll be left with 1 over x plus 12, right? There you go. Number 10, right? Remember, x minus 7 all squared means I'm going to write this twice. Okay, so this is going to be x minus 7 times x minus 7, all right? And then again, this is different two squares on the bottom, so I got x plus 7, x minus 7. Okay, so I am going to get rid of these, and what's left is my answer. I got x minus 7 over x plus 7. Okay, all right, number 11. Let's factor both the top and the bottom. All right, so I got y plus y plus y plus y plus. All right, 5 times 5 is 25 and adds to 10, so it's going to be 5 and 5 on top. 40, that's going to be adds to 13, that's going to be 5 and 8, so 5 and 8. Now, in class, I say this a lot of times, but if you know on top that I have a y plus 5 and a y plus 5, it'd be really nice if a y plus 5 showed up in the bottom, So let that be your guide. If you get stuck on, all right, what times what is 40 and adds to 13, right? Maybe it's going to be a y plus 5, right? So does 5 times anything equal 40 and also add to 13, right? Let that be your guide on how to solve this if you get stuck. And so what's left is my answer, y plus 5 over y plus 8. Okay, okay, now on number 12, you have a perfect cube. And so this is going to break down into a binomial and a trinomial. And everything hinges on this binomial. You take the cube root of the first term, so it's going to be y. The cube root of 216 is going to be 6. All right, and then the trinomial is built off of the binomial. You square your first term, so it's going to be y squared. It was the original was minus, so it's going to be plus. Multiply your two terms together, so it's going to be 6y. That's going to be plus because you square your last term. And when you square, it's always positive. It's going to be plus 36. Okay. I have y minus 6 on the bottom, so these two are going to fall out. And that trinomial is what's left, and that's my answer. All right. Number 13. All right, number 13. You can multiply first and then reduce, or you can reduce first. If I catch it in time, I always like to reduce first. So 5 goes into 5 one time and 48 times. X squared goes into x squared one time, and x squared goes into x cubed with one x left over. Okay, so that's 2 times 8 on top, so 16. And then 1 times x on the bottom. So there's your answer, 16 over x. Right, for any of these, if you have more questions about how I worked it or like me to work it a different way, bring your questions to class and we'll talk about it. Or come see me in my office. All right, number 14. Let's break apart every one of these. Again, your best friend is this thing in factored form. So if it's not already in factored form or not all parts are in factored form, you want to get there as soon as possible because that's when you know when you can get rid of stuff. All right, so on top, I'm gonna take a 5 out, so it's gonna be p minus 1 over p times 5p squared over, we'll take a 6 out, p minus 1. All right, I can get rid of the p minus 1. I can't get rid of the 5s because they're both on top. Now we need one on top and one on bottom to get rid of them. P goes in P one time and P goes in P squared P times. Okay. So that's going to be 5 times 5 is 25. It's 25P over 6. All right. Number 15. You drop down here. All right. So that's going to be setting everything up. Okay. On the top, you have K plus 5K plus 6. This would be K plus K plus. All right. What times what is 6 and multiply and adds to 5? All right. Your factors in 6 are 1 and 6 and 2 and 3, both of which can be manipulated and give you 5. Which one works? One of them starts big and goes small, which is subtraction. The other two add to 5, which would be 2 and 3. So be careful with that. All right. On the bottom, you have k squared plus 7k equal plus 10. That's going to be k plus All right, and it's going to be 2 and 5. All right. On top here, I don't need a factor a binomial and polynomial. I just need a GCF. So it's going to be k times k plus 5. On the last one, I got k plus 3 times 3 is 9, and it adds 6, so 3 and 3. Let's get rid of what I can. I got plus 2 plus 3 plus 3 plus 5 plus 5. And I'm left with k over k plus 3. So all of this junk simplifies to something as simple as that. Good stuff. So again, number 16. Okay. This time, actually, I'm going to factor everything into binomials. I had one holdout last time, but this time I have no holdouts. All right, so this is going to be x minus. Again, the second sign is positive, which tells me both sides are the same, and they're both the same as that middle sign. So minus minus. All right, 6 times 9 is 54, and adds to 15. X minus, x minus. That's going to be 3 and 12. X minus, x minus. That's going to be 3 and 8. X minus, x minus. That's going to be 2 and 9. Okay, let's get rid of what I can. I got a minus 3 and a minus 3, minus 9, and that's it. So not as much cancel as it did last time, but still going to get rid of enough. So I got x minus 6, x minus 8 on top, over x minus 12, x minus 2. There's absolutely no reason for me to multiply this out um, on top or bottom. There's absolutely no reason for that. So don't. You can if you want to. It's just a waste of time because if it was going to cancel or anything else is going to happen, it would have already happened. Right? The simplest form is factored form. And so again, if it's not gonna if it hasn't happened yet, it's not gonna happen. And so multiplying everything out doesn't help you. You might could use the practice, but it doesn't help you simplify the problem anymore. Number 17. Right? We have a perfect cube on top. So it's a binomial and a trinomial. Right? Look at the one on the bottom. You have a trinomial that every term has an x. Maybe that's going to play a part in the trinomial that I'm going to have to build. Right? So I'm going to have x plus 1 here, x squared minus, because I take the opposite sign of the original. Right? There's going to be 1 times x is 1x, so it's going to be minus x plus 1. Okay, I'm going to take out a GCF on the bottom, so it's going to be x squared minus x plus 1. That's familiar. We got 6x. I'm going to factor out a negative 48. Why negative 48? Well, obviously 48, but if I take out the negative, that's going to become a positive x and a plus 1, which is what I want. All right. Again, don't look at every term in isolation. Look at what's around you in the problem. Let's see if you can get one of the things that's already there to show up again, because then you can get rid of it potentially. All right. So I can get rid of the x plus 1s. I can get rid of the trinomials here, and get rid of this x and this x. 6 goes into 6 one time. 6 goes into 48 8 times. Don't forget about the negative. A lot of students forget about that negative. So it's going to be 1 over negative 8 or negative 1/8 or something like that. Um, remember that negative can float. It can be up top, up front, or below. So I'll let you decide. Yeah, negative 1 is your answer there. All right, 18 is our first division problem. It's pretty much the same process, but one subtle difference. Okay, so I'm going to factor out a 3 here, y minus 1 over y. Now, um, you have to change it to a multiplication and flip to second fraction. So it's going to be 8y squared on top. And then I'm going to factor out a 10. So it's going to be 10 y minus 1. All right. So the y minus 1 is going to leave. 8 goes in there, or 2 goes in 8 4 times, and 10 5 times. Get rid of the y's, y left over. Okay, so it's going to be 3 times 4 times y is 12y over 5. Okay. Right. As these things get more and more complicated, right, take as much time and room as you need. Okay. But I'm going to have to factor everything. And if you need to flip that fraction and then factor, that's fine too. So let's see. We got x plus x plus. It's going to be 4 and 5 plus 4 plus 5. X plus 5 5. On the bottom, I got x plus 4. On the top, it's going to be x plus minus. It's going to be plus 5 minus 7. Okay, so I get rid of plus 5 plus 5 plus 5 plus 5 plus 4 plus 4. And I'm left with x minus 7 over x. Okay, 20. Let's see, we have 5y plus 2, 4x plus 5. So interesting thing about 20 here is I have x's and y's that I have to keep up with. So just be careful with that. Real quick, I have 4 terms on top here. So this is going to factor by grouping. So that's going to be y, the first one, x minus 5. And I take out a plus 2, gives me x minus 5. Okay. So the next step will be my last step on that one. And that's going to be um, x minus 5 and y plus 2. Remember that because it's division and I'm changing it to multiplication, that numerator is now going to come to the bottom. So that's going to be x minus 5 times 5 is 25 and adds to 10. All right. So get rid of, get rid of plus 5. So let's go out. Plus 2 minus 5 minus 5. And I'm left with 5 times x minus 5 on top, 4 times x plus 5 on the bottom. Okay. All right, 21. We have to multiply and divide. And 20 in that first fraction, we have to factor it by the AC method. So pay close attention to what I'm doing. So number 21, I'm going to take the 5 and I'm going to multiply it to the back end. Multiply it to the back end. Okay, so that's going to be x squared plus 8x minus 105. Well, you need to know the factors of 105. And that's going to be 1 and 105, 2, 2 going to into it, 3 and 35, 5 and 21, 7 and 15. And I want to know which of these multiplies to 105, which they all do. And also, because my signs are going to be different, because that second sign is negative, we got x plus, x minus, which one subtract to give me 8? Yep, it's going to be 7, 15. And the middle term is positive. So the bigger of the two factors, 15, gets the positive sign. So plus 15 minus 7. Now remember with the AC method, because I multiply by 5 to begin with, I have to undo that. So I divide both of these numbers by 5, and I reduce where I can. So x over 15, or 15 over 5 is going to be x plus 3. All right, and then 7 over 5 doesn't reduce. So I'm going to take this 5 and kick it in front of the x. And so that's going to be 5 over x minus 7. Now, I'm going to take that, and I'm going to plug it into the top. So I got x plus 3, 5x minus 7. That'll be the hardest one that we have to factor in this problem. Then I'm going to take a GCF out. It's going to be 2 times x minus 2 times. You have a difference of 2 squares. Or sorry, you do, but not in the top. Okay, so that's going to be a GCF on top. That's going to be x times x minus 2. On the bottom, you have 5x plus 7, 5x minus 7. So we factored this first term with the AC method, and we had this 5x minus 7 showed up. And you probably thought that that was not going to be able to cancel, right? Shame on you, right? If it shows up in part of your problem, it might show up in the rest of it. So don't discount it, right? And in fact, it might be helpful if you recognize that that's a difference, 2 squares in that bottom of the second fraction. And then recognize that, hey, that 5x and 7 might show up. Okay, so times, and this one I have to flip. So 5x cubed, and pull out 7, and it's going to be x plus 3. Okay, so I can get rid of the x plus 3s, x minus 2s, 5x minus 7. Let's see, and I think that's all I can get rid of. Yep. So I got an x and a 5x cubed on top, so that's going to be 5x to the fourth. I have a 2, 5x plus 7 is 7. That's going to be 14 times 5x plus 7. Okay, and that's it for that one. A lot going on there. All right, so I'm 22. We're going to shift gears and move away from the multiplying and dividing, and we're going to focus on um, adding and subtracting fractions. And we're going to start with one that is pretty straightforward. We just simply need to get, we already have like denominators, so I can just go ahead and add. And I'm not going to change the bottom of I'm not going to change the denominator, but I am going to factor it. So we'll pull a 3 out, and that's going to be x plus 5, because you want everything in factored form, just in case. All right, 38x minus 20x is going to be 18x. You have a positive 180 and a minus 90, so that's going to be plus 90. Okay, if you know your 5 times tables, you might recognize that 18, if I pull out an 18, I can get an x plus 5 to show up. even if you don't recognize it, try. Right? You ever had this is one of the reasons why I went ahead and factored that denominator. And I said 3 times x plus 5. See if you can't manipulate. Maybe you can, maybe you can't, but at least try to get an x plus 5 to show up on top. Don't force it, but give it a shot. If I pull out an 18, I get x plus 5 to show up. 3 times x plus 5. I can get rid of the x plus 5s. And then 3 goes in 3 one time, and 18 6 times. And so this nasty thing turned into just a simple number of 6, which, again, is a beautiful thing. Okay. On number 3, or sorry, 23, I'm going to get this in factored form on the bottom. It's already the same, so I don't need to worry about that. But it's going to be x squared, x plus x minus. It's going to be 6 and 2 plus 6 minus 2. Okay. And then I got 10x minus 9x. That's going to be x. And 1 minus 3 is -2. So again, another reason why I factored, because something I might be able to get rid of something. So this is going to be 1 over x plus 6 for my final answer here. All right. On 24, again, I have common denominators. I still would like to get that in factored form. Okay. So I'm going to have x minus 4 on top. Maybe I can get x minus 4 to show up on the bottom. We got x plus minus, what times 40 for unit 6? It'll be 4 and 10. And the middle term's positive, it's going to be plus 10 minus 4. Again, I would like x minus 4 to show up, but I can't force it. So, but it does show up, so I can get rid of it. It's going to be 1 over x plus 10. Okay. All right. 25. At the halfway point. All right. So everything is over x plus 4. X plus 4, it can't be factored, so I'm just going to bring it down. So you got 7x plus 5x minus 6x. 7 and 5 is 12. Minus 6 is 6. So it's going to be 6x minus 4. Nothing I can do with that. I mean, I could take out a 2, but again, it doesn't help me. So there's that. Now, starting with 26, our denominators are not exactly the same. We need to adjust. This is the same thing as, let's see, 9 over x minus 7 plus 2 over, if I factor out a negative, I can get the x minus 7 to show up, which means this is the same as 9 minus 2 over x minus 7. So it's going to be 7 over x minus 7. All right, once again, you have x minus, or x over, or minus 36 minus 6 over. If I take a negative out, I can get the x squared minus 36 to show up again. But because the top is already x minus 6, I can bring this negative up, I get x plus 6. Also, you may recognize that x squared minus 36 is a difference of 2 squares. So this is going to be x plus 6, x minus 6. So I can get rid of the x plus 6's. And my answer is going to be 1 over x minus 6. Okay, on 28, it's not quite as simple. You have an 8x and 9x. They have an x in common, but they don't have. So on the right, whatever you do to the top, whatever you do to the bottom, you have to do the top. You have to leave it. You have to balance everything. So the right fraction needs an 8. So I'm going to multiply by 8 over 8. The right fraction needs 9, so I'm going to multiply by 9 over 9. That's going to give me the denominator that I want, which is 72x. So that's going to be 72x. 9 times 3 is 27, plus 8 times 5 is 40. So 40 over 72x. 27 and 40 is going to be 67 over 72x. And that won't factor. So that is my answer. That you can't simplify that any further. 29. All right, this is similar to 28. They need, but they don't have. It just so happens that each one needs a binomial. So I'm going to multiply this one by x plus 4 over x plus 4. Remember, anything over itself is 1. So I'm just multiplying the other fractions by 1 or some equivalent fraction to 1. X minus 4 over x minus 4. Which allows me to manipulate the problem without changing the problem. If you change the problem, that's a problem. So let's figure this out. We got 6 times x minus 4 minus 2 times x plus 4 all over x plus 4, x minus 4. Again, there's no sense in multiplying this out. No sense at all. Just leave it in factored form. All right, let's clean this up. All right, we got 6x minus 24 minus 2x minus 8. X plus 4, x minus 4. 6x minus 2x, that's going to be 4x negative 28, or sorry, negative 24 minus 8 is going to be minus 32. X plus 4, X minus 4. All right. I can take a 4 out of the top. So that's going to be 4 times X minus 8. That's not going to help me. So I'll leave it here. This is my answer. All right. On 28 and 29, you knew what they both sides needed at the jump. You need a factor. You need a factor to begin with on 30. So you have 7x minus 2. It'd be really nice if I get that show up again. So 9 goes in 63 and 18. If I pull out a 9, you get 7x minus 2. Well, there it is. So it means I need the left side just to have a 9. So 9 over 9. All right. So that's going to be 9x minus 2 over 9 times 7x minus 2. All right. I can't do anything with that. But everything looks good. So this is my answer. And we're 2 pages in, 2 pages left. All right, 31, 32, 33. These are the last ones that we have to work on as far as rational expressions go, and then we shift gears to start talking about inequalities. So we're going to pick up the pace here shortly. All right, 31. We need to get a common denominator, but I don't know what I don't know until I factor each one of these out. So let's factor this. Oops, that's going to be x plus x plus. That's going to be 4 and 7. X plus x minus. Okay, so this is going to be 7 and 3. So plus 7 minus 3. So they both have plus 7. Okay, so I need to multiply this one by x plus 4 over x plus 4. They need to be multiplied by what they don't currently have. Okay, and then I'm going to multiply this one by x over x minus 3 over x minus 3. Okay, so when I come down here on top, and then I have x plus 3, x minus 3. And I'll multiply that together in a second. But and then I have 5 x plus 6 times x plus 4 all over my new denominator of x minus 3, x plus 4, and x plus 7. All right, like I said, I need to multiply all that out and clean it up. All right, so this is going to be x squared minus 3x plus 3x minus 9 plus 5x times x is 5x squared. It's going to be 20x, 6x, and 24 all over x plus 3, x plus 4, x plus 7. Okay, now let's see what I can get rid of. Let's see, I have minus 3x plus 3x, and that's as much as I can get rid of, but I can combine the rest. Okay, let's see. I got x squared and 5x squared. That's going to be 6x squared. Let's see. I got 20x and 6x is going to be plus 26x plus 24. X plus 3, x plus 4, x plus 7. It will not factor any further. You could try to factor the top by AC method, but it's not going to work. So that's going to be your answer. Okay, on 32, the first one is x times x plus 5. So I don't need to touch the first one. The first one is going to be my common denominator. The second one, I need to multiply by the x plus 5 over x plus 5. And then the last one needs an x over x. Okay, so this is going to be 20, because I don't have to touch anything, plus 7 x plus 5 plus 4 x all over x times x plus 5. Okay, let's multiply that out. That's going to be 20 plus 7x plus 5, or sorry, plus 35 plus 4x all over my denominator. Okay, it's going to be 7 and 4 is 11x. 20 and 35 is 55. You see what I see? I can take out an 11 up top and give me an x plus 5 to show up. Think about that. So my answer is going to be 11 over x. Beautiful. 33. We have a minus and a plus, and we have all the denominators that are not the same. So this is going to take a second, but we can get it done. So this is going to be 3 times x minus 2. This is going to be 2 times x plus 1. This is going to be 5 times x plus 2. Again, they all need what they don't have. So on the left, the far left, they have a common denominator is going to be 30. 3 times 2 is 6 times 5 is 30. So 30 x minus 2 plus 1 x plus 2. And I write it out like this because I want to figure out what I need. All right, I need a 10 x plus 1 x plus 2. Okay, so it's going to give me a 20 x plus 1 x plus 2. Okay, so we'll come back to that. Let's see. Here, I need a 15 uh, x minus 2 x plus 2. Right, which is going to give me minus 15 x minus 2 x plus 2. Okay, and the last one needs 6 times x minus 2 x plus 1. All right, which is going to result in plus 6 x minus 2 x plus 1. Okay, so we need to multiply this out. This is going to be 20 x squared plus 2x plus 1 x plus 2 minus 15 x squared minus 4. It's going to be a difference. That's a breakdown of a difference of two squares. Plus 6 times x squared minus um, plus x plus 1x minus 2x minus 2 all over 30 plus 2 plus 1 plus 2. Okay, this is going to be x squared plus 3x plus, let me do that differently. It's going to be x squared plus 3x plus 2. This is going to be x squared minus x minus 2. Okay, so we have 20 x squared plus 60 x plus 40 minus 15x squared plus 60 plus 6x squared minus 6x minus 12 all over my denominator. 30 x plus 2 x plus 1 x plus 2. Let's see, I have 20 x squared minus 15x squared. It's 25x squared plus 6. It's going to be 11 x squared. We have 60x. So I had x squared, x squared, x squared, x, x, constant, constant, constant. Okay, so that's going to be plus 54x. So you got 60 minus 6. And then 40 plus 60 is 100, minus 12 is 88, and plus 88 over x plus 2, x plus 1, x plus 2. Again, you could factor the top by the AC method, assuming you have a factor, but it's not going to help you. So I know that was a lot, but that's your answer. All right, shifting gears completely. Let's talk about inequalities. So we're shifting from chapter 7 to chapter 9 here. Okay, 34, we're going to divide by -9. And that's going to give me x is greater than +5. Because remember, if I multiply or divide by a negative, this is probably the most critical rule when it comes to inequality. If you multiply or divide by a negative, you have to flip your inequality sign. So it's going to be x is greater than 5, and it's going to be, and when I subtract the 3 here, it's going to be, or the 9, it's going to be greater than 3. Okay, well, let's draw our number line and graph this thing. Okay, so I have a 3, I have a 5. On top, I'm going to graph, shade to the left, open parentheses on 3, shade to the left, open parentheses on 5, shade to, or both of these are shaded to the right. Remember, if you write your inequalities from left to right, the inequality points in the direction that you're going to shade. Okay. And because this is an and statement, I have to cut it off. All right. And is exclusive. It has to check the box. It says it's true for both statements at the same time. So it's from here and over. So which inequality does that? Well, it's going to be the x is greater than 5. So, and so when I write that, that's going to be 5 parentheses infinity. Okay. And there's that. Right. Number 9, or sorry, number 35. I'm going to subtract 3 from everywhere. And that's going to give me a 6 less than or equal to 2x less than or equal to 14. And then I'm going to divide by 2. And because I'm dividing by 2 and a negative 2, I can leave my signs alone. But this is going to be 3 less than or equal to x less than or equal to 7. And from here, I graph. And because it's a compound inequality like this, I'm going to put my graph on the same level. So this will be 3, 7, um, bracket, 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 3 in between. So that's going to be 3, comma 7, bracket on both sides. And that's your interval. 36, same thing. Add 5 to everywhere. So it's going to be negative 30 less than or equal to negative 5x less than negative, add 5 to both sides, going to be negative 10. Now I'm going to multiply by negative, sorry, divide by negative 5 everywhere. So that means I'm going to flip my inequalities. So I'm going to divide this, going to be positive 6 greater than or equal to x greater than positive 2. All right, we don't write compound inequalities in the direction. It's usually less than and less than. So I'm going to rewrite this in the other order, in the correct order rather. So 2 less than x less than or equal to 6. Okay, so from here, I can draw my line. 2, 6. And because 2 is, there's no bar under there, it's going to be a parentheses. And then for 6, it's going to be a bracket and then shade in between. Okay. And so that's going to be 2 comma 6 parentheses on 2 bracket on 6. There you go. So let me remind you, when it comes to inequalities, you can write the inequality, you can write your solution as an inequality, as a graph, as a um, interval notation. So it's important to know all three so you can move between all three. If you don't know, the inequality is usually pretty straightforward because that's usually what you get when you're working with inequalities and you're like solving like a normal equation and then going from there to the graph is pretty straightforward. Students seem to struggle the most with interval notation, but if you can get to the graph, you can get to the interval notation, no problem. So just be mindful of that. You might need a graph first, but all is well. Okay, on 37, I'm going to subtract 8 from everywhere. So it's going to be 7 less than equal to 7 x over 3 less than equal to 21. Now, I'm going to take care of this in one fell swoop. I'm going to multiply everything by that reciprocal. So it's going to be 3 over 7. 3 over 7. Okay, so 7 goes into 7 one time. 1 times 3 is 3. That's equal to 7x over, oops. And I'll multiply by that too. So it's just x on the inside. And then 7 goes into 21 3 times. 3 times 3 is 9. There's that. So let's do my graph. It's going to be 3. It's going to be 9. Okay, that's going to be bracket on both sides. Stayed in between. So that's going to be 3 comma 9. Bracket on both sides. Here you go. 38. So if you were back in class, I put a similar problem on the board, and I told you that I would tell you what numbers belong on either side of the compound inequality. And so that's what we're doing here. So we have 5 over 9, f minus 32 on the inside, and it says inclusive. So it's going to be less than or equal to, less than or equal to, negative 30, and 10. Okay. So again, just like 37, I'm going to multiply by the reciprocal on both sides. So, or all sides, all beginning, middle, and end. So it's going to be 9 over 5, 9 over 5. And when I get to the middle, I'll just drop the fraction. Okay, so this is going to be 5 goes into negative 30. 6 times, and 6 times 9 is 54, and don't forget it's negative. Okay, less than or equal to, remember I'm dropping the fraction because I multiplied everything by it. That's be f minus 32, less than or equal to, 5 goes into 10 twice, 2 times 18 is, so 2 times 9 is 18, right? And I'm gonna add 32 everywhere, so let me show that. So it's gonna be negative 54 plus 32 is gonna be negative 22, less than f, less than, and then 18 plus 32 is 50. Okay, so I don't need a graph on this one. I just need to rewrite this as interval notation. So this is negative 22 degrees Fahrenheit, 50 degrees Fahrenheit, bracket on both sides because it's all inclusive. Okay. So when it comes to these word problems or application problems, you don't always need the graph. A lot of times they just want you to write it in interval notation. Okay, we just problem did this in class. On 39, it says, on the first 4 exams, your grades are 78, 88, 67, and 79. You're hoping to earn a C in a course. This will occur if the average of your 5 exams is greater than or equal to 70 and less than 80. Okay, so you have 78 plus 88 plus 67 plus 79 plus X all over 5, because you're taking the average, dividing by 5, and uh, greater than or equal to 70. But remember, this is in between, so I'm going to write it like this, and then less than 80, because it says greater than or equal to 70, and then it says less than 80. So be careful with that. When I multiply everything by 5, this is going to be 350. When I add these numbers up, that's going to be 312 plus X less than 400. All right, I'm going to subtract 312 from everywhere. Okay, so that's going to be 38 less than or equal to X less than 88. If you remember in class, we were trying to keep a B. And so we could get as high as a 125 on our initial calculation, but you don't usually see a 125 on a test. It's usually out of 100. So keep that in mind. This one doesn't go over 100, so I don't have to make that adjustment. So this is going to be my answer here. Okay. On 40, it says parts for an automobile repair cost $280. The mechanic charges $40 per hour. If you receive an estimate for at least $520 and at most $680 for fixing the car, what is the time interval that the mechanic will be working? So you're going to write essentially a linear expression, and then you're going to put your least and your most on either ends of it. So $40 per hour, so that's 40x. Repair costs are 280. That's a flat fee, so plus 280. All right, at least 520. So it could be 520, but it could also be greater than. So that's going to be 520 less than or equal to, and then at most, so it can't be more than, but it can be 680. So you have less than or equal to on both sides. You're going to subtract 280 from everywhere. Okay, and so that's going to give you 240 less than or equal to 40x less than or equal to 400. Okay, so when you divide by 40, it's going to give you 6 less than or equal to x less than or equal to 10. Again, I don't need a graph, but this just tells you that the mechanic is going to work between 6 and 10 hours to fit within these prices. So 6 comma 10 bracket on both sides, and that is my answer. Okay, now an or statement. Let's take a look at this. On number 41, we're going to subtract both sides. uh, from -1 on both sides, so it's going to be -5x greater than or equal to 10. And I'm going to divide by -5, so it's going to be x is less than or equal to -2. Okay, and then I do the or part of this. This is going to be 4x greater than or equal to -16. X is greater than or equal to -4. Notice I flipped my sign on the first one. I didn't flip my sign on the second one, even though both answers are negative. I divided by negative on the first one. I divided by -5, and the second one I only divided by +4. It matters what you divide by, not what your answer is. So be careful with that. All right, so we're going back to our graph here. Okay, so that's going to be -2. Oops, it's going to be -4, -2. Um, so less than or equal to -2. So bracket shade to the left, bracket shade to the right. when is this going to be? All right, so and says it has to check both boxes at the same time. So it has to satisfy both solutions at the same time. Here it says you can satisfy either solution. As long as you satisfy one, it works. So because of this overlap on an or statement, that means if I'm going from left to right, I never have to pick up my pencil. So when is this true? Always. And how do you write that in interval notation? Negative infinity to positive infinity, like so. Okay. Absolute values. Okay, remember absolute value cannot be negative. All right. And so because it's distance, and distance can't be negative, distance from zero. Okay. If the absolute value is not by itself, like on 42, it's not by itself. It has a plus two with it. So you need to get it by itself first. So whether that is to multiply or divide or add, subtract, you got to get the absolute value by itself before you work with the absolute value itself. Okay. So I'm going to subtract two from both sides. Everything looks fine here. And I subtract, you get x. The absolute value is, let me subtract, it's going to be -8. Remember, I just said the distance can't be negative. Now, if there was a negative sitting out here, then we could talk. But there's not. So there's nothing I can plug in to this absolute value that's going to result in a -8. So in this situation, there's no solution because there's nothing I can plug in there that's going to work. So no solution there. All right. Here, I'm going to move this. It says going to be 2x plus 9, absolute value equals 5. Okay, subtract the 2, you get the 5. Now, you work with this by doing, you want to drop the absolute value. You're going to say 2x plus 9 equals 5. But remember, the inside could also be negative. So I'm going to say, or 2x plus 9 equals -5. Okay, so equals 5 equals -5. And I work both to figure out what my answers are. So you got 2x equals, it's going to be -4, x equals -2, 2x equals -14, x equals -7. So x equals -2 or -7. Okay, and that's how you do that. All right, last page, going to 50. 44. On 44, you have an absolute value equal to another absolute value. Well, you treat it the same way. Okay, so 3x plus 5 equals 3x minus 5. Or, and this is where a lot of students get hung up because it's equal to an absolute value, but it's the same process. The first one equals both the positive and the negative version of this. We already did the positive version, but now we're going to do the negative. So we're going to do negative, open parentheses, 3x minus 5, close parentheses, and now we have our setup and we work both. Okay, so we get rid of our 3x on both sides. So minus 3x, and that's going to result in a 5 equals -5. Well, we all know that's not true. 5 does not equal -5, and so that one hit a wall. Here, we have 3x plus 5 equals -3x plus 5 because I distribute the negative. Now I'm going to add 3x to both sides, and this one is not going to cause everything to fall apart. This is going to be 6x plus 5 equals 5, and then when I subtract 5, this is going to be 6x equals 0. So x equals 0. Well, the first problem already fell apart, so this is all I got. If I plug in 0, then they're equal. If not, nothing else matters. Okay. Now, when you combine inequalities with absolute values, there's a couple things you need to look out for. You want to make sure your absolute values, just like any inequality, you want to write them from left to right. So your absolute value, your variable should be on the left side and everything that follows, because this is where all the tips and tricks come from, is based off of them being written left to right. Okay, so you have 7x plus 1 absolute value. I'm going to add the 1 to both sides. So it's going to be less than 5. Okay, now this wasn't going to change anything by adding 1 to both sides, but when you have an and next to the, when you have an and next to the absolute value, this is going to result in an and statement, which means I can write this as 7x plus 1 less than 4 and less than -4. So I can write it like this, where it's in between the two. This only happens for an and statement. Okay, so I'm going to subtract 1 from both sides. So it'll be -5 less than 7x plus 1, or 7x less than, it's going to be 3. And so this is going to be -5/7 less than x less than 3/7. All right, so I'm going to draw my line. Mm, Draw my line. It's going to be -5/7, +3/7. Okay, look at the wrong one. It's going to be 5. It's going to be 6. It's going to be 4. So this should be 6/7, 4/7. Okay. All right. Now that I got that fixed, this is going to be in between. So parentheses, parentheses, shade in between. Okay, and then when it comes to your interval, this is going to be -6/7, 4/7, parentheses on both sides. Okay, 46. Again, this is an and statement because it's a less than here. All right, let's see what happens. If I have to do this, this is going to be 1 minus x over 2 less than um, 5 minus 2 is 3. So there you go. Because it's less than, I can write it like this. -3 less than or equal to 1 minus x over 2 less than or equal to 3. We'll subtract 1 from everywhere, so -4 less than or equal to x over 2 negative less than or equal to subtract 1, that's going to be 2. I'm going to multiply by -2, so it's going to be +8 greater than or equal to x greater than or equal to -4. I'm going to write this in the correct order, so it's going to be -4 less than or equal to x less than or equal to 8. This is going to be -4 comma 8. Again, draw my line. -4, 8. I have brackets on both sides and shading in between. Okay. So this is going to be -4 comma 8 bracket on both sides. There you go. Now, again, you always want to get this thing by itself before you make any decisions. It's going to be 2x plus 2 absolute value. When I subtract or add 3 to both sides, it's going to be less than -5. The distance can't be negative. So when is this is asking you, when is this absolute value going to be less than -5? Well, if it can't be negative, it can't be less than -5. And so this is never or no solution. Okay. 48. So if you have a less than next to this, it's an and statement. If you have a greater than or greater than or equal to, then this is an or statement. Or statement. Okay, so that changes things slightly. This is going to be x minus 4, absolute value, greater than or equal to, it's going to be 5. Okay, so for this one, this is going to be x minus 4 is greater than or equal to 5, or x minus 4 is less than or equal to -5. Okay, I don't have the compound inequality anymore, but this is how you write it. All right, so this is going to be x is greater than or equal to, I'm going to add the 4, so this is going to be 9. X is less than or equal to, I'm going to add the 4, that's going to be -1. Okay, so I'm going to draw my line. Okay, it's going to be -1, 9. Um, less than -1, greater than 9. So let's see, greater than equal to. There you go. So that's going to be, how do you write that in interval notation? Well, again, your number line is from -infinity to +infinity. So I start with -infinity if it's included. And in this case, it is because it's shaded to the left and shaded to the right. So in parentheses always pairs with infinity. So you get -1. -1 has a bracket union because that's what the symbol for or, and then bracket 9 to infinity. Okay, there you go. Two more. Okay, so on number 49, you have to clean up the inside a little bit. So let's do 2x plus 2 plus 4, actually like greater than 6. All right, there's going to be 2x plus 6 greater than or equal to 6. All right, it's greater than. So this is going to be an or statement. Okay, so this is going to be 2x plus 6 greater than or equal to 6, or 2x plus 6 less than or equal to -6. So let's see, it's going to be 2x greater than or equal to 0, x is greater than or equal to 0, 2x less than or equal to, it's going to be -12, x is less than or equal to -6. Down the line. All right, yeah, -6 and 0, greater than 0, less than -6. So it's going to be bracket on both sides, shade to the left, shade to the right. Okay, so that's going to be -infinity, comma, -6, bracket, union, bracket, 0 to infinity. Parentheses. Here you go. Last one. All right. So we have 8x plus 1 greater than. I'm going to add 2 to both sides. It's going to be greater than negative 4. Again, it can't. The absolute value can't be negative. Okay. So if it can't be negative, it's always going to be positive, and a positive number is always greater than negative 4. So in this situation, we had one earlier that was it never worked, like 47. It never worked, all right, because it can't be less than negative 5. It can't be less than 0. All right, but it can be greater than 0, and 0 is always greater than negative 4. So this is always. How we write always in interval notation? Well, it's gonna be negative infinity to infinity. Negative infinity to infinity. Okay. Okay, and then if you want to know what the line looks like, you're just shading the whole thing. Shading the whole thing. You don't want to overwhelm the line, so I'm gonna keep it short, but you get the idea. All right. So that is rational expressions and inequalities and absolute values. Uh, so if you have any questions, please bring them to class or come to my office and we'll talk about it. Good luck on your test, and I will see you in the next video.